Hi astronomers, Caroline here. So far we've been exploring the inner terrestrial planets of our solar system. But what about the outer planets beyond them? Will they be similar or different from the terrestrial planets? Could one of them be better suited for a crewed mission than Mars? If not, what discoveries might these distant planets hold that could change our understanding of the solar system and beyond? Let's take a journey to explore the next two planets, Jupiter and Saturn. First, we'll compare and contrast their size and composition with the terrestrial planets. Then we'll explore the features that make Jupiter and Saturn even more unique, like their turbulent atmospheres, number of moons, and spectacular rings. As we dive into the wonders of Jupiter and Saturn, we might just uncover clues that will help shape the future of space exploration. We've learned that the terrestrial planets, Mercury, Venus, Earth, and Mars, are small, rocky, and close to the Sun. Now, let's think about Jupiter and Saturn, which are much larger and farther from the Sun. These two planets are known as the gas giants. Why do you think they are called that? Consider how they might be different from the terrestrial planets and use those differences to help you define what makes gas giants a unique class of planets. Pause your video and record your prediction in your notes. Close to the Sun, rocks and metals came together to form the rocky terrestrial planets. Jupiter and Saturn formed beyond the frost line, where it was cold enough for substances like water, ammonia, and methane to freeze into ices, creating more materials. As Jupiter and Saturn pulled in ice, rocks, and metals, what happened to their gravity? Their gravity grew stronger. This allowed them to attract even more material, eventually making their diameters about 10 times bigger than Earth's. When compared with the other planets, their size is staggering. The fact that the outer planets are so big and have such strong gravity means that they pull in asteroids that might otherwise have been on a path to Earth. Whew. So now we have an understanding of their gravity and the giant part of their name. But where did the gas part of their name come from? As the mass of their cores and gravity increased, they were able to pull in light gases like hydrogen and helium that the terrestrial planets were just too small to hold on to. And even under the thick layer of gases, you won't find land. Instead, there are layers of liquid and metallic hydrogen and cores of unknown compositions. Considering what Jupiter and Saturn are made of, do you think it would be possible to send a crewed mission to them? You've probably come to the conclusion that landing on the gas giants is highly unlikely because we wouldn't have a surface to land on. But what else can we learn from them? It turns out that many exoplanets, planets outside of our solar system, are similar to the gas giants. So by studying Jupiter and Saturn even from afar, we can learn more about our universe. We can also gain knowledge from observing their turbulent atmospheres and storm patterns. Here on Earth, our land works as a force to slow down storms. Think of how a hurricane weakens when it hits land. How long might storms last on the gas giants? Without land, the storms on the gas giants can last hundreds of years. Gas giants share many characteristics, but Jupiter and Saturn also have features that set them apart from each other. Take a moment to observe the photo of Jupiter's atmosphere. You can think of the photo like a map. Scientists took the 3D globe and laid it out flat. There's a lot going on here when you look closely, and even more when we think about how the atmosphere is moving. You may have noticed the light and dark bands stretch around the planet. Jupiter rotates very quickly. One day is just 10.5 Earth hours. The fast movement creates these bands, or jet streams, that are moving in different directions at different speeds. There are also a number of spots. What do you think those might be? Those are storms. Some are small, dark ovals, while others, like the Great Red Spot, are much larger and longer lasting. At its largest, the Great Red Spot was bigger than 3 Earths across, and is believed to have been raging for over 300 years. It is fueled by the strong winds faster than any tornado, and without land to interfere, it just keeps going. Jupiter isn't just famous for its storms. Its magnetic field is also one of the strongest in the solar system. In fact, Jupiter's magnetic field is about 20,000 times stronger than Earth's and extends well past all of its many moons. This powerful field is created by the movement of metallic hydrogen deep inside the planet. Remember when we learned about the solar wind and how it affects Earth? It reaches Jupiter too, and these charged particles from the sun get trapped in Jupiter's intense magnetic field, forming strong radiation belts around Jupiter. Any spacecraft that gets too close has to be carefully shielded from this radiation. But if we were flying by Jupiter, we might be able to see its faint rings. They are hard to see from Earth and were only discovered in 1979 when the spacecraft Voyager flew by Jupiter. In addition to rings, Jupiter has around 100 moons. We'll explore these moons in more detail in a later lesson, but the rocky moon, Europa, is of particular interest because there are vast oceans under an icy crust. Would sending a crewed mission to a moon of Jupiter be an option since we can't land on the planet itself? Could that also be a possibility with Saturn? Saturn has even more moons than Jupiter, each with its own set of unique characteristics. Like Jupiter's moon, Europa, Saturn's moon, Enceladus, looks promising for future missions, with land and global oceans under a thick, icy shell. Sometimes moons get torn apart into smaller pieces by gravity and become part of the ring system of a planet. Saturn's beautiful rings are made of shattered moons, comets, and asteroids. These pieces of rocks and ice coated with dust create 7 main groups of magnificent rings around Saturn. We already know Saturn is significantly bigger than any of the terrestrial planets we've learned about so far. In addition to its massive size, the rings extend even further, hundreds of thousands of miles out. They're so dazzling both because of the size and how the large ice and rock pieces reflect the light of the sun. So we know that Jupiter and Saturn are massive, and you may have guessed that they exert a strong gravitational pull on any objects around them. Does that mean that they also have high densities? Actually, no. Jupiter and Saturn may be enormous, but did you know they are actually much less dense than Earth? Jupiter, the biggest planet, is only about 1/4 as dense as our rocky planet. And Saturn? It's even less dense. So much so that if you could find an ocean big enough, Saturn would actually float because it's less dense than water. Why do you think Jupiter and Saturn have such low densities? It's their composition. They are made mostly of hydrogen and helium, the lightest elements in the universe. While their massive size gives them strong gravity, they're mostly made of gases rather than heavier rock and metal like the terrestrial planets. That's why their densities are so different. As we end our journey to the gas giants, you now know that Jupiter and Saturn are huge planets made mostly of the gases hydrogen and helium that cover a liquid layer and core. Some of their moons have oceans of water beneath a thick layer of ice, and they have turbulent, stormy atmospheres and rings. Jupiter is known for its Great Red Spot, a storm that's been raging for hundreds of years, while Saturn is known for its spectacular reflective rings of ice and rocks. As scientists continue to study these outer planets, what groundbreaking discoveries might they make? We may not be able to send a crewed mission to the planet itself, but perhaps instead we'll visit one of their rocky moons. Be sure to check out the activities for this lesson, and next time we'll explore the last two planets, Neptune and Uranus, the ice giants. And always remember, you are out of this world. See you next time.
Hey, hey.